Good afternoon, students. So we are starting with our next problem. So our eighth problem, see the question, mod x by x if x is not equal to 0, 0 if x is equal to 0. Of your mod functions, I have said you the questions how we have to solve. Here they have conditions given, 1 if x is not equal to 0, second if x is equal to 0. So whenever mod is there, I have said you first we have to check, right? So here mod x, because mod x will be having what? X if x is greater than or equal to 0, minus x if x is less than 0. Mod x, mod is always termed as plus and minus, right? Plus is when greater than or equal to, minus when less than. So we are using that form. So whenever a mod part is there, first we have to verify. Now here they have said x is not equal to 0, which means when they have said x is not equal to 0, which means it is less than also and it is greater than also. Less than 0, greater than 0. For both it follows the rule. So given function can be written as x by x if x is greater than 0. Why x mod x, x y I have taken? Because if x is greater than or equal to 0, the mod x is what? X. So for greater than 0 it is x. Only for numerator it is mod. So for numerator only you are writing it. X, your denominator remains as it is. Greater than 0 became, next is what? For less than 0. Mod x for less than 0 it will be what? Minus x. So minus x by x if x is less than 0. Third is what? 0 only, 0 if x is not equal to 0. So here you see, if I cut x, x, x1 za, x1 za, so I get 1 only, right? So one more time I have written f of x is equal to 1 if x is greater than 0. This also, right? x1 za, but here minus 1 if x is less than 0, 0 if x is equal to 0. Okay, again I have written it. Now in this, greater than 0, less than 0, equal to 0. 3 cases. Here when equal to, what I have said, for equal to sign only, go for LHL and RHL in your branched function. Okay, in your singular function and only one single question they have given, that time go for your limit and your at that point and all. But in this, only for x is equal to 0, you should go for LHL, RHL and at that point. So we will see our case 1. First when c is equal to 0. Okay, c only we have to take. I have said you case 1 when c is greater than 0. When c is greater than 0, what is our f of x? F of x is equal to 1. When c is greater than 0, our f of x is greater than 1. And 1, it is a constant function, right? So what we can do? I can't substitute anything. And what I have said, constant function is continuous. So it is a constant function and every constant function is continuous. Same, our case 2 will be less than 0, c less than 0. C less than 0 is what? X less than 0, f of x is what? Minus 1. This is also a constant function, so same, it is a constant function and every constant function is continuous. Hence, f is continuous function when c is greater than 0 and c is less than 0. For both it is constant, right? So we are getting the same. Now case 3 when x is equal to 0, that is when c is equal to 0. Hence, f of x when c is equal to 0, what it is? F of x is 0. And at this point, at f of 0 also, what we will get? 0 itself, right? Because whatever your input is, output you are getting the same. If your input is greater than x greater than 0, like if your x is greater than 1, output what you will get? 1 itself. Greater than 2, you will get 1 itself, because it is constant everything. Here also, it is equal to 0, it is 0. So f of 0 also will be what? 0. Now we will find LHL and RHL. LHL means I have said you less than. So limit f of x as x tends to 0 minus, LHL superscript will be minus. So 0 minus means what? Less than. Here x less than f of x is what? See, you have to check the conditions. X less than is what? Minus 1. So f of x is what? Minus 1. So limit f of x will be minus 1 and x tends to 0. See here no x value that I can substitute, so it remains as it is, minus 1. Constant term remains as it is. RHL means greater than, limit f of x as x tends to 0 plus we will give and our greater than. So in this, which is greater than? X is greater than 0, f of x is what? 1. So limit f of x is 1 as x tends to 0 and same you get 1. here you see your LHL is not equal to RHL. So you can see LHL is not equal to RHL, hence f is not continuous at c is equal to 0. Therefore, c is equal to 0 is the only point of discontinuity. The question they have asked, which is the point where the function is not continuous, that is discontinuity. C greater than 0 we are getting continuous function, C less than 0 we are getting continuous function. Only C is equal to 0, here our LHL is not equal to RHL. So, it is not continuity only at C is equal to 0 at this point. I hope it is clear for you. Your next question, see your 9th question, f of x equal to x by mod x if x is less than 0 minus 1 if x is greater than equal to 0. Your previous question how it was? Mod x by x it was. Here it is what? X by mod x, right? So, in denominator mod is there. But here your condition you see, here they have given the condition x less than 0. So, mod x value only for less than 0 it changes, right? As I have said you, mod x is whatever x if x is greater than or equal to 0 minus x if x is less than 0. So, in place of mod x whatever the condition we gives that changes, right? So, the given function can be written as f of x, x by mod x. When x less than 0 it becomes what? Minus x. When x is less than 0 your mod x value will be what? Minus x. And the next is minus 1 if x is greater than or equal to 0. Now again here you see x1 gets off, right? Minus 1 I get because here minus 1 is there. So once again I am writing f of x is equal to minus 1 if x is less than 0. Here also second part minus 1 if x is greater than equal to 0. Here you see for x less than 0 also you are getting minus 1, for greater than equal to 0 also you are getting minus 1 only. So, whatever your input is, your output you are getting only one term, that is minus 1. Minus 1 is a constant function. So, obvious it is continuous. Here there is no point of discontinuity. For 3 conditions also, less than, greater than, equal to, you are getting only one number. Yes. So, f of x is equal to minus 1 for all real numbers. Yes, for any real number if you take, you are getting minus 1 itself. Now, suppose if I take x is less than 0 means x is whatever minus 1. If I take minus 1 also you are getting minus 1, minus 2 you will get minus 1 only. Here f of x is minus 1 is a constant function and every constant function is continuous. Hence, there is no point of discontinuity. Understood? Next question you see, what they are asking, is the function defined by f of x is equal to x plus phi if x is less than equal to 1, x minus phi if x is greater than 1, a continuous function. This also sorry, same way you have to do as you have done for 6th problem. Yes, first for x less than 1 you have to check, x greater than 1 and x equal to 1. At equal to 1 you should go for LHL and RHL. Yes, that method you try it, you do it. I am doing in your graphical way also. I will show you how we do it. By graphically also how we can tell the point is the function is continuous or no. Now x and f of x, right? 2 values are there. 2 functions they have given, x plus 5 and x minus 5. I am taking normal points 1, 2, 3, 4, 5 I am taking. 0 I have kept here. 1, 2, 3, 4, 5 positive side, minus 1, minus 2, minus 3, minus 4, minus 5 negative side, right? Both they have given because x greater than 1 also, x less than also. X greater than 1 values, x less than, which also points you can take. It is not necessary what I have taken, you also to take it, just for an example to show you. Okay. So, now you see x 1, 2, 3, 4 means these are greater than, right? Positive means greater than, minus means negative. F of x you see, for greater than your f of x is what? X minus 5. So, whatever your x value is there, you put in this and what value you get f of x, you are writing it. First when I put, when x is 5, 5 minus 5 is 0. When x is 4, see this is greater than, positive terms are greater than. So, in this which is f of x, you have to see the first condition, x greater than is here. So, you have to go, okay, f of x is this, so you have to put here. You should be so sharp in that. So 4 minus 5 is minus 1. Again next we put 3. 3 minus 5 is minus 2. Next our number is 2. 2 minus 5 is minus 3. Next number is 1. 1 minus 5 is minus 4. Next is 0. 0 minus 5 is minus 5. Next is x less than equal to 1. See, minus 1, minus 2 is less than term. So less than is where you have to check here. So when x is minus 1, minus 1 plus 4 is minus 1 plus 5 is 4. Minus 2 plus 5 is 3. Minus 3 plus 5 is 2. Minus 4 plus 5 is 1. Minus 5 plus 5 is 0. See, first you have to put the numbers. You have drawn the graphs, right? Taking x values and you will get the y values. So here y is whatever f of x. Now I am drawing the graph. Up to 6 I have taken because till 5 I am getting just 1.6. Positive side, negative side, x axis, y axis, x, y, x dash, y dash. Now you see, from wherever you start, 0, if I start from here, for 0 it is what? Minus 5. So 0 minus 5, where it is mine? Here. So I have marked the point. Either go like this or like this, it is your wish, wherever. For minus 1 is where mine in x axis? Here. Minus 1, my f of x is what? Y axis 4. For minus 1 it is 4. Minus 2 is here. Minus 2, what is the f of x? 3. Y value is 3. So minus 2, where is 3? 3. For minus 3, where is my minus 3? Minus 3 is here. For minus 3 it is what? 2. So where is the value? 2. Minus 4, 1. So what is the value? 1. For minus 5 it is 0 and draw a line. Same way for here you go. For 1 what you are getting? 1 is minus 4. 1 is minus 4. For 0 minus 5 already I have done. For 1 it is minus 4. For 2 it is minus 3. For 3 it is minus 2. For 4 it is minus 1. For 5 it is 0 itself. When it is 5 it is 0 only. So it lies here only, right? You are drawing here line. Now what I had said you at the start, drawing a graph without lifting pen, we call this as continuous. Now here you see this line, no doubt you can draw without lifting the pen. This is one line, but one more graph is here. This both you can, no doubt you can draw it without lifting pen. But the both we are considering it as a graph, right? This both you have to lift only. So from this only we understand that it is not continuous. Understood? In a graphical way you have to do like this. Take x value, anything, take any value and then check it out, put your y values. This f of x means it is equal to y. F of x means it is equal to y. So graphically it is in such a way. You try to do in your theoretical method also the same as we have done for the 6th question.